So student, today we will discuss about the oxygen dissociation curve, and before all the topics we have done, so I hope they were clear. So in oxygen dissociation curve of hemoglobin is a graph, children, okay, which showing the percent of saturation of hemoglobin with the changes in pressure of oxygen at constant pH. What I said? Constant pH एक ही है, okay, and how much oxygen is bind with hemoglobin. ये hemoglobin के साथ कितना ऑक्सीजन जुड़ेगा, that is only we will understand by the oxygen dissociation curve. Basically it's a oxygen dissociation association curve. Are you getting my point? But in NCERT it has given, so we will read it accordingly only. So basically just try to understand it. PO2 means pressure of oxygen. Clear? Suppose it's hemoglobin, and hemoglobin is having 4 sides, you know very well, and it's oxygen. Okay, so how oxygen will bind with this hemoglobin in a pressure? If you increase pressure of oxygen बढ़े तो hemoglobin से ज़्यादा जुड़ना चाहिए. Okay, so we will read it because you know they are having high affinity of binding. Hemoglobin is having high affinity with the association of oxygen. So affinity का pressure से क्या effect होता है? Okay, this we will understand by this structure only. So here you can see that this side is of pressure of oxygen and here is a saturation of hemoglobin and it is in percentage. कितना hemoglobin जुड़ेगा oxygen के साथ? Okay, so this is the curve between of it. So here you can see when you increase pressure, शुरू में ऑक्सीजन हीमोग्लोबिन के साथ एकदम से नहीं जुड़ता है. ओके, सो इन स्टार्टिंग इफ यू इंक्रीज pressure of oxygen, so that time slowly the percent of oxygen saturation of hemoglobin will be there. Means you can observe it here. You can see 20. Here you can see 20 and that time are you able to check it that only 20% of hemoglobin is attached with it. Okay, but from 20 to 30, can you see there 30? Here pressure is 28 mmHg. Can you see? Pressure of 28 mmHg. That time here is a 28. Okay, so that time you can see the affinity is goes towards the 50%. पहले देखो स्टार्टिंग में बेटा धीरे धीरे बढ़ रहा है, बट अचानक से in this portion you can see a very rapid growth or association. Is it true? And when the carbon pressure reached 40 mmHg, that time you can see that it's the highest peak of bond, that is of the 75% of hemoglobin can affinited or associated with oxygen. आप प्रेशर धीरे धीरे ऑक्सीजन का प्रेशर बढ़ा रहे हो, बट यू कैन सी व्हेन द प्रेशर इज इंक्रीजिंग स्लोली, बट देयर इज अ ग्रेट डिफरेंस बिटवीन द हीमोग्लोबिन कितना जल्दी जुड़ रहा है इफ़ यू इंक्रीज प्रेशर. ओके, इसको एक स्मूथ रेट से होना चाहिए था बेटा, बट दैट इज़ नॉट पॉसिबल बिकॉज इन स्टार्टिंग हीमोग्लोबिन ऑक्सीजन से जुड़ नहीं रहा था, धीरे धीरे ऐड हो रहा था. बट इफ़ यू इंक्रीज प्रेशर in a same way, at a point come where the affinity is more. Okay, hemoglobin ज़्यादा जुड़ने लग गया ऑक्सीजन के साथ. So this is the area where you can see that the here only 10% difference is there and here you can see almost 25% difference is there. Are you getting my point? I hope I am clear. Okay, so after it you can see that after 75% of this saturation, it reduced blood returning from tissues about oxygen, then oxygenated blood leaving to the lungs. It means that अब इस हिस्से में you can see here in this portion, especially in that portion, if you increase pressure but that time the affinity is not increasing in that much level, Children, you can observe 40 to 60. You can observe here 40 to 60. It's of 75. Or in 60, you can see here only the 15% difference is there. In 20, यहाँ देखो प्रेशर में 20 का डिफरेंस है, बट हेयर ओनली 15. Are you getting my point? So there is only one area where the association of hemoglobin is and oxygen is very high. Okay, so the curve shows that there is a progressive increase in the percent of saturation of hemoglobin with the increase of PO2. Okay, up to the level in 30% at 20 mm. 20 mm approx it gets to be 30%, then 75% at 40. Please remember this term, 75% at 40 mmHg, and 97% at, you can see here, now come to the 97%. Here you can see, children, 97%. Okay, 97% above at about 95 mmHg. So overall we can say that the shape of normal oxygen dissociation curve is sigmoid. S जैसा बन रहा है ना बेटा, S. So that's why it's known as the sigmoid curve. Okay, I hope that much is clear. If you have any question, please send me your question, children. Or factors affecting oxygen dissociation curve we will discuss in our next video. Thank you.